National Electrical Code Section 334.30 code addresses the securement and support of Type MC cable. It states that Type MC cable shall not be strapped, stapled, or fastened to building surfaces in such a manner that will damage the cable sheath. This provision aims to protect the integrity of the cable and ensure its long-term reliability and safety. While Article 300.11 primarily discusses securing raceways and cables, including the use of ceiling tie wires for support, the core issue revolves around preventing damage to the cable itself. The use of an airline, presumably referring to pneumatic tubing or hose to suspend MC cable from steel structures to a fixture on a machine, raises concerns about whether this method could potentially damage the cable sheath. The prohibition is based on the potential for damage, not necessarily the specific material used for support. Let's delve into the reasons why using an airline might be problematic and explore alternative compliant methods for supporting MC cable. Firstly, material compatibility is a significant factor. The airline material might not be compatible with the MC cable jacket. Over time, chemical reactions or physical interactions could degrade the cable jacket, leading to premature failure. Secondly, securement methods are also very important. If the airline is simply tied or wrapped around the MC cable, it could create pressure points or sharp bends that damage the sheath. The weight of the cable, combined with vibrations from the machine, could exacerbate this issue. Thirdly, consider the support intervals. Improperly spaced supports can cause the cable to sag or strain, potentially damaging the conductors or insulation within the cable. The code specifies appropriate support intervals to prevent this. Now, let's discuss compliant alternatives for supporting MC cable in an industrial environment. Firstly, cable trays are a widely used and effective method for supporting multiple cables in industrial settings. Cable trays provide continuous support, minimizing stress on the cables and allowing for easy routing and maintenance. Secondly, approved cable straps and clamps designed specifically for MC cable are readily available. These straps and clamps are typically made of metal or plastic and are designed to securely hold the cable without damaging the sheath. They should be installed at the intervals specified in the National Electrical Code. Thirdly, individual cable supports such as J-hooks or bridle rings can be used to support MC cable from structural members. These supports should be properly sized and installed to prevent damage to the cable. It is important to use appropriate hardware, such as screws or bolts, to securely attach the supports to the steel structure. Now, let's discuss the specific implications of National Electrical Code Section 334.30, securely fastened. Type MC cable must be securely fastened in place. Firstly, securing and supporting of cables. MC cable must be supported and secured at intervals not exceeding 6 feet. Secondly, horizontal runs through holes and notches. In other than dwelling units, where not subject to physical damage, unsupported cables are permitted to be installed. Firstly, where the cables are run through holes drilled through joists, rafters, or wood members, and secondly, where the cables are run through notches in joists, rafters, or wood members that are protected by steel plates or sleeves to protect the cable from nails or screws. Thirdly, cables containing circuit conductors of 120 volts or less, 150 volts to ground or less, or cables containing Class 2 or Class 3 circuits shall be permitted to be surface mounted on a finished surface. This section means to install the cable securely. Now, let's consider National Electrical Code Section 334.30b supports. Type MC cable must be supported in accordance with one of the following. Firstly, cable ties or straps. Cables must be secured with cable ties or straps listed and identified for securement and support, and installed in accordance with the listing. Secondly, cable trays. Cables must be supported by cable trays. Thirdly, cable cleats. Cables must be supported by cable cleats. Fourthly, other support methods. Cables must be supported by other methods that provide equivalent support. The NEC is updated regularly, so it's crucial to consult the latest edition for the most current requirements. Now let's talk about some of the general wiring methods. Firstly, raceways and cable assemblies must be supported in accordance with their corresponding articles. Secondly, wiring systems installed behind panels designed to allow access must be supported to prevent undue stress in the conductors. Thirdly, ceiling support wires and associated hardware must not be used as the primary support for raceways. This section emphasizes the importance of using appropriate support methods for different wiring systems. Now, let's talk about raceways and cable assemblies. Firstly, raceways must be securely supported. Secondly, cable assemblies must be supported in accordance with their corresponding articles. This section emphasizes the importance of using appropriate support methods for different wiring systems. Now, let's discuss the issue of abandoned cables. The National Electrical Code requires that abandoned cables be removed. This is to prevent confusion and potential hazard. Abandoned cables can create a fire hazard and can also interfere with the operation of other electrical systems. Now, let's talk about the importance of proper grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage and prevent electrical shock. Now let's talk about the importance of using listed equipment. Listed equipment has been tested and certified by a qualified testing laboratory, such as Underwriters Laboratories or Intertech. Listed equipment is more likely to be safe and reliable. Using listed equipment is also a requirement of the National Electrical Code. Now, let's consider the plant's concern about code violations. The plant is correct to be concerned about code violations. Code violations can create a safety hazard and can also result in fines and penalties. It is important to ensure that all electrical work is performed in accordance with the National Electrical Code and other applicable codes and standards. Now let's consider the local inspector's approval of the installation. The fact that the local inspector approved the installation does not necessarily mean that the installation is compliant with the National Electrical Code. Inspectors can make mistakes, and they may not always be aware of all of the applicable code requirements. Ultimately, it is the responsibility of the electrical contractor to ensure that all electrical work is performed in accordance with the National Electrical Code. It is also important to remember that the National Electrical Code is a minimum standard. In some cases, it may be necessary to exceed the requirements of the National Electrical Code to ensure electrical safety. The specific requirements for supporting MC cable can vary depending on the application and the local codes. It is always best to consult with a qualified electrical engineer or inspector to ensure that the installation is compliant with all applicable requirements. The installation of electrical systems in industrial environments must adhere strictly to the National Electrical Code and any local amendments. The use of inappropriate materials or methods for supporting MC cable can compromise the safety and reliability of the electrical system. By understanding the requirements of the National Electrical Code and using compliant support methods, you can ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. In conclusion, while the local inspector may have initially passed the installation, the plant's concern regarding the use of an airline to support MC cable is valid. National Electrical Code Section 334.30 code prohibits any method of strapping or fastening that could damage the cable sheath. The airline support method presents a risk of damage due to material incompatibility, inadequate securement, and potential for strain on the cable. Therefore, it is recommended to replace the airline support with compliant alternatives such as cable trays, approved cable straps, or individual cable supports, ensuring that the supports are properly installed and spaced according to the National Electrical Code requirements. This will ensure the long-term safety and reliability of the electrical installation. Ensure all installations adhere to the latest edition of the National Electrical Code and local amendments. Proper installation is paramount for electrical safety.